Thank you. Yes, so I'm Chris Laughlin, I'm Principal UI Engineer at Rapid7. I'm a freelance writer for SitePoint and LogRocket, and I create small, fun, hopefully, tech talks on TikTok. Come on, there we go. So, immutability in programming refers to data that cannot be changed or cannot be changed after it's created. So let's take an example of what mutation is before we can think about immutability. So this example, we're looking at a library book being taken out, and you grab that book and you decide to draw a smiley face on one of the pages. I don't advocate doing that. As doing this, you then change that original copy of that library book. That book will always have that alteration, and we can never know what it was before you scribbled that smiley face over the top of the page. When we think about immutability, again, same using the library example, you take a book out, but in this case, instead of just taking the book directly, you make a copy, so you photocopy it. Again, I don't know if that's copyright infringement or illegal, but don't take my word for it. So we take our book, we draw the smiley face on the book again, so we're defacing a library book, but this doesn't alter the original book. We made a change to the copy. So we always have that original book. There's a history of whatever that was. And we think about this in the sense of state management and JavaScript programming. So let's look at some code. So we all want to see loads of code on the screen. So in JavaScript, there's kind of two main kind of ways of declaring variables, let or const. So we have a let variable, so name is Chris. We can then reassign the value of that to be Christopher, and then when we log it out, name is now Christopher. So the original value that we had with those Chris has become Christopher. If we create a constant variable, so we create a speaker, which has a name, location, and age, and I'm looking well for 100 years old. When we try to reassign the speaker object, we get a JavaScript error because by nature, consts can't be reassigned. It's only read-only. Now, consts do have some quirks, and when it comes to using JavaScript, and I always feel that they're not really a constant variable when we think of the term when it comes to programming. If I do speaker.name equals Christopher, and then I log out speaker, the name is now changed. So the original value, so that original library book, has been modified, and we don't know what the original name of the speaker was. So we can use ways to get around this in JavaScript. So in the last couple of years, the spread operator was added to this JavaScript spec. So we can, again, take our object, our speaker, we can then create a new object called full name speaker, and then we spread that original speaker in. So using those three little dots is kind of like saying explode this object into a new object. And it's very useful because it's very dynamic. We don't need to think about, what other attributes the speaker has. Then when we say speaker.name equals Christopher, if we log out our speaker and our full name speaker, we can see speaker kept the name Chris, full name speaker is Christopher. So we didn't modify that original value, and that's the same as photocopying our book in the library. But then things get a bit more complicated, and this is where, I always think of the spread operator as your kind of introduction into immutability in JavaScript. So again, we start off with our speaker object, which has a name, and our location now is its own object itself. So it's a nested object onto our speaker, which is our location. So its city is Belfast, country UK. If we do the spread operator like we did in our last example, so we spread speaker into full name speaker, so we're exploding those attributes into the new one. Then we want to do some modifications on that. So we can say full speaker.location.city equals Derry. So I've moved city. When we log out both of these, we can see here both of these speaker and the full name speaker both have the city set to Derry. So we've actually still modified that original value. We've broken the rule of immutability. We've mutated the original value. We've lost that history and state. So now we've kind of come into a pitfall, and this is because of nested attributes on objects don't get copied. The spread operator is, by default, a shallow copy, so it'll not go through the nested values. And this is kind of the concept of assignment by reference, not assignment by value. So what we're saying is copy and make a new version of name and age, but for location, point to the original location that we had. So that's the location in our original speaker, not our full name speaker. So there's a way around this, obviously. And again, recently in the JavaScript language, they're evolving and they're moving more towards immutability. The structure clone function was added to the library spec. So what we can say now, instead of just doing a spread, we can do a structure clone of our speaker. And this is a deep copy. So when we do our modification on location.city equals Derry, our original speaker is still set to Belfast, and our new speaker is set to Derry. There's some other utility functions and concepts in JavaScript that allow you to manage immutability. I rarely see these being used often, but they are very useful. So object.freeze, what this is saying is freeze an object completely and allow no modifications to it. So we can see speaker.name equals Christopher. In our previous examples, when we just had a plain const, you could have done that, but JavaScript will now complain an error. There's also object.seal. So it's a little bit different, where it's saying lock this object as it is, and still allow modifications to the values, but don't allow any additions to it. So we can change the name, but when we try and change or add an occupation to our speaker which didn't have it before, JavaScript throws an error. So let's look at a real world example. It will probably not be as fancy as Paul's. So let's take the example of we have the immutable ware shop. Thanks to AI for generating all the code and the puns and based on this. So we've immutable ware shop, and in our shop we can click add to cart, and we have a shopping cart that we have here. But say we want to then modify this to put point symbols, so indicate what the currency is on each of the items. We may jump into VS Code, and we have a React component that lists through all of our products. So we can see here we're mapping over products, rendering them. So the bad way of doing this would be to map for each over each of these and modify what the price value is to put the point symbol on that. So if we go back to our example, we can see now we have the point symbols. We have indicated our currency. But if we start adding items to our cart, so this overpriced jacket, we can see here we've caused a bug. We have a bunch of point symbols. Our total's kind of gone off, so something's went wrong here, and we're not doing things correctly. We for each and modified the original value, which again broke the concept of mutability. And now we've got a bad scenario. So what we really should have done is comment that out, and instead of mutating the data, change how we display the data. So we didn't have to modify the original data. We just put the point symbol into our markup. We could have created a new array of products as well and modified the values so they achieve the same. But sometimes you don't need to modify data to actually achieve what you're trying to do. And for sanity, we go back to our site. Refresh. We still have our point symbol, so we achieved what our ticket was to add currency, and we haven't broken anything. So let's jump back. So as we kind of seen there, immutability was focusing on arrays, and arrays is the big areas where we're dealing with like data, and we're iterating through data, we're manipulating data, and this is where we need to think about the immutable ways of handling things. We have all these different methods. Some mutate the data, some do immutability. But then recently, again, as the JavaScript spec's been evolving and growing, it's been moving more and more towards immutability as a paradigm and pushing the idea of functional programming very heavily in JavaScript itself. So in the ES 2023 spec, there was a bunch of array methods added. So let's take a look at some of those. So one of the key ones you might use when you're dealing with arrays, maybe it's strings or data, is the reverse arrays. So previously we had the reverse method on arrays, which would have changed the underlying array, breaking that history, breaking that immutability pattern. So now we have this toReverse function, so you can call that, and instead of mutating the original array, it'll return a brand new array that's mutated. And when we log out our examples, we can see this is all handled. And there's a kind of theme, they're all following a to something because you're creating something new from the method. Similar for, two examples for reversed. Similar for sort. So we have the sort method, which again, we use a lot of times when we want to like sort tables, we want to sort data based on items. We can call sort. There's also a toSort method. Same for splice. Splice is useful for either removing items from arrays, modifying existing items in arrays. We want to do this in an immutable way, so we now have the toSpliced method. As well as this, it's not just the things that are built into the JavaScript spec. There's some well-known libraries like Immutable and Immer, which are widely used to kind of force immutability and use immutable patterns when you're working with JavaScript. And these kind of allow you to delve deeper into immutability as a concept and not just be restricted by what the language provides. And they make it easier to kind of wrap around things so you're not having to handcraft a lot of it for you. So in conclusion, I hope that when you're thinking about building web applications, backend applications, applications to do with data and objects and arrays, you think about immutability as a pattern to manage state, manage how your application flows, and not break those linkages and histories to what you've done before. And thank you.